Hello everyone, welcome to my session. In this session, I'm going to explore you one of the most efficient string searching algorithm, and this is also called as pattern matching algorithm. And these are all the outline of my presentation. Introduction to Boyer-Moore algorithm, design technique which is used, examples and the time complexity. Let us start with introduction to Boyer-Moore algorithm. Boyer-Moore algorithm is a most efficient string searching algorithm, which is used to find the given pattern in the text. I'll take one simple example of normal uh, text. Let's say I want to find ring in computer science and engineering. So, whereas in engineering, ring word appears at the end of your string. So, let me take an example of normal naive string matching algorithm. What you're supposed to do here is you're supposed to keep on matching the character one by one. Let's say your pattern is ring, your computer will be there. Computer science and engineering means computer will be there. You're going to check ring with COMP. That is not going to match. Again, you shift your character one shift right side, one shift right side, one shift right side. This is called as a naive method to check every character one by one. But whereas in Boyer-Moore algorithm, it is smarter. It skips over parts of the text using clever logic. So it is particularly effective when the pattern is relatively long compared to the size of the alphabet. So how does it work then? So key concept of this Boyer-Moore algorithm is you are going to perform the pattern matching from right to left instead of left to right. And there are some two characteristics we have in this Boyer-Moore algorithm, which means this uses two different tables. Okay, of course it works from right to the left, which means you're going to shift the character, okay, the character from left to right, and the character comparison happens from right to left, starting with the last character of the pattern. If there is a mismatch, it doesn't just move one step forward. Instead of, it uses two main rules. One is the bad character rule, another one is good suffix rule. These two tables you're supposed to consider to shift the given pattern. Let us understand these two rules. What is bad character heuristic table? Suppose if mismatch happens when we shift the given pattern so that the mismatched character in the text aligns with the last occurrence of the character in the given pattern. If it is not in the given pattern at all, we skip the pattern completely past that character. So for that we have a formula. We'll discuss the formula in upcoming slides. And one more thing is good suffix rule. This is also called it as a good suffix table. If you come across end of the given pattern, but the pattern matches, but mismatch occurs. Let's say only two characters matched. Next immediate third character is not matched. In that case, we shift the pattern so that another occurrence of the pattern, patching pattern part or suffix lines of the uh, particular text. So by combining these two rules, the algorithm avoids unnecessary comparisons, making it very fast in practice, especially with large text. Finally, I would like to say Boyer-Moore is most powerful algorithm because it skips sections of the text instead of checking every position. It's widely used in text editors, searching tools, even in the DNA sequence as well. Okay, so let us go with the algorithm. What you're supposed to do in algorithm. First, you pre-process the given pattern. by generating good character table and as well as good suffix table. I mean, sorry, bad character table and as well as good suffix table. Align the pattern at the beginning of the text. Compare the pattern from right to left. If mismatch occurs, use the large of shift suggested by two heuristics. Repeat until you get the text, or else until you were character means the complete string text should be reached at the end. This is the simple algorithm. Let us take an example of this is my pattern BAOBAB. This is my pattern. How your bad shift table looks like. This bad shift table is similar to your hospital algorithm. You just take an example of this one. See, you're supposed to, according to the algorithm, you're supposed to match the character from right to the left, which means from this character, you should match the character of a given string. Okay, so suppose if this is the last characters, if you are matching with this last character means no need to combine this particular value with any other uh, characters in the given text, so that easily you can skip I mean easily you can shift the entire length of the given string. Okay, but when this character occurs, suppose in the given text A will be there, A is matching, uh, B is matching. So B is not matched, only A is matched in the given character means you're supposed to shift the given pattern by one character right side. So that is what is it is mentioned here. That is why your A value here is 1. Okay, initially your B value was 6 actually, but in this case what happens, B is repeated in the given pattern. So that B shift to table value is 2. Why B shift to table value is 2? Because after B there are two characters. So your B shift to table value is 2 and A shift to table value is 1. Why A shift table value is 1? Because next to A only one character is there here. Again you consider O. So which means suppose if this particular value is matched means how many characters I should shift this particular pattern. So that is taken care by this bad shift table. Here, suppose if O is matched means the shift to table value would be 1, 2, 3. How many characters are there after O? 3 characters we have. So the O shift to table value is 3. Okay. Again, one more A is there here. So suppose if this character is matched, you observe one thing, A is already repeated here. But excluding this value, suppose if B comes anywhere in the given pattern, you just take the previous occurrence value. Here also A is there, you just consider previous occurrence value. Here the previous occurrence value is 1. So now you take B. So B means B is already appeared here, excluding this value. So how many characters we have? 1, 2. So 1, 2, 2, you just write down 2. Okay. So suppose if any other characters comes underscores, spaces, if anything comes, except BAO, BAB, any other characters like D, E, F, G, H, I, J, K, L, M, P, Q, R, S, T, U, V, W, X, Y, Z. If any other characters comes, you just write down that bad shift table value is 0, 6. Okay. Now we need to compute D1 value. So what is D1 value? D1 value is nothing but this is the shift value. Okay, where how you this D1 is calculated, for that we have formula. What does this formula says that? So D1 is equals to T of C minus K. So T of C is nothing but the value of the bad shift table. Suppose if any one character is matched, suppose if O is matched means what is the character shift table value of O is here is 3. Just take down 3. Suppose what is the character value of K now? So K is nothing but this is nothing but the number of matching characters. So what is number of matching character means? Suppose in your given string, last character is matched, last but one character is not matched. In that case, you consider not matched character value as T of C, and character, how many characters matched here? Only one character matched, which means the K value becomes 1. Okay, I'll take with example so that you'll understand what is the value of D1, DC and K. Then how to build good suffix table. This is very, very important. So here you're supposed to consider how many characters matched in the given string. Actually, your K value initially should starts from 0 actually. So 0 means there are no characters matched. So if there are no characters matched, it means obviously the shift value should be Z6. And then that acts as a D2 value. That is why this 0th character match I haven't considered directly. I considered one character match in the given text. So now your character K, which means one character is matched, then what is the value of D2? So here, so one character is matched means observe one more pattern if whether this B is repeated in the given pattern or not. Is anywhere in this given pattern this B is repeated? Yes, B is repeated. Where? Here B is repeated and here B is repeated. And what is the least occurrence of this B from right to left? And this is the least occurrence of B. After B, how many characters we have? So we have 1 and 2. So 2 characters we have, just write down 2. Suppose if this B was there in this position means what is the value of B? So B, suppose if B was there in this given position means you're supposed to consider 1, 2 and 3. So this is the D2, shift value is 2. Okay. So now only one character is matched. Suppose if two characters are matched. Two characters means what are the characters we have? B and A. So A, B both are matched, but next third character is not matched. If that is the case, then what is the value of shift table value? Here you observe one thing, AB is not present, but B is present here. One more thing, see, suppose when it comes to the example, the previous case, what we considered here, so B is there here. Again, you check whether this B is repeated in the given pattern or not. So here B is repeated, here B is repeated. So if two characters are matched means AB means anywhere in the given pattern whether AB is repeated, check whether it is repeated or not. Here AB is repeated, here AB is repeated, here AB, no, in nowhere your AB value is repeated. Suppose if B was there in this case means, suppose if B was there in this case means, so here AB is matched. So which means then the value should be how many characters we have after this AB? 1, 2, 3. Just write down 3. Suppose if B was there means here B is not there. Then what is the value? If B was not there means obviously only A is matched here, but B is not matched. So very simple thing here. If AB is there, B is not there, only A is there means simply take this value and check how many characters we have from this character. So 1, 2, 3, 4. So from A, how many characters we have? You just take the next immediate occurrence of a particular element. So here AB is not there. Directly you can shift your value by 5 times. Okay. And one more thing. Here next thing is three characters match. So B A B. So here is your BAB anywhere is repeated here. Nowhere BAB is repeated. But AB is repeated here. Nowhere AB is repeated. But B is present here. So B is present means, so you just consider, see where your B is there, your B is there here. Consider this 1, 2, 3, 4, 5. So you just consider 5 value as your shift table value. Okay. So this is how you can construct good suffix table. And how to find the D2 value here. So how to find this D2 value? For that, I mean, this D2 is nothing but the shifting value. How this shifting value is calculated? Based on this formula. maximum of T of C comma 1. So whichever you find it as a maximum value, just consider that and take it as a pattern shift value. Okay, now let us take one example and let us build this table. So we have a table here. This is my good suffix table. This is my bad heuristic table. We have both the table here. This is one table and this is another table. This is my good suffix table and this is my bad character shift table, or else this is also called it as bad shift heuristic table. So this is my string now. Best knew about Bob. This is the string. And the pattern is B A O B A B. This is the pattern. So first we should consider the value like this shift value. What is this shift value? Here shift 0 means nowhere the shift happens. In just you place your pattern with respect to the given string. Okay. And you just observe one thing. According to the algorithm, you're supposed to match the character from right side to left, but the pattern is placed from left to right. See, this is important. Pattern is placed from left to right, and the pattern matching happens from right side to left side. From this side, pattern matching happens. Okay, now you just check with this. So K and B, is this characters are matched? No, these two characters are not matched. Then what you should do? You're supposed to consider calculate the value of D1. If there are no characters matched, directly you take the value from bad shift table. If character is matched, then take the value from the good suffix table. This is important. So now here there are no characters matched, and now which character is not matched here? So K is the character which is not matched. Then you take you just consider the value D1 is equals to T of K minus K. What is this K? This K is nothing but this value. And what is the K value in your bat suffix table? In your bat suffix table, if any other value is there, means you're supposed to consider K value as 6. So here T of K is nothing but 6. How many characters matched in this given pattern? No characters are matched, then the value is 0. So 6 minus 0 is 6. D1 is the shift value now. So now what you should do? So once this character shift table you found means shift your character by 6 times right side. So now 6 times your character table, I mean the pattern is moved towards right side. Okay, now what you should do? Now you just consider the pattern matching kind of thing. So here, so B and B is matched. You check again from left, right to left only you check. Here B and B is matched. A and A is matched. Underscore and B is not matched. So then, so shift 1 happened already. So in shift 1, you're supposed to calculate the shift value for next shift. So here, how many characters matched? Here, two characters matched. A and B, two characters are matched. And which character is not matched? Underscore character is not matched. Then you calculate D1. First, you calculate D1. So T of underscore. T of underscore means what is the shift table value of underscore? Underscore shift table value here is 6. You just consider 6 here. How many characters matched here? Two characters matched. You just write down this value. 6 minus 2 is equals to 4. Now we found D1. See, in previous cases, no character matched happened. Directly you took the D1 value and shifted your pattern towards right side by 6 times. But here, two characters are matched. So if two characters matched means you're supposed to consider D2 value as well. Okay, what is the value of D2? If two characters matched, what is the value of D2? If two characters matched means the D2 value is 5. This is very, very important. And now you take this shift value S is equals to max of D1 and D2. What is D1? My D1 value here is 4 and my D2 value here is 5. So out of 5 and 6, which is the maximum value? Maximum value is 5. Consider this 5 as the shift value. This is important. Now, so how many times I should shift the characters? 5 times I should shift the given pattern. So now again same thing happens here. You just check whether all the characters are matched from right side to left side. So is this character matched here? Yes, this character is matched, and here this character is not matched. See, observe one thing here. If B, so here also B is there, here also B is there. Obviously, this B should be matched with this B value. So that based on this value, remaining all other value will be considered. So that is the beauty of this Bayer-Moore algorithm. So here B and B is matched and A and underscore is again not matched. So if character is not matched means first calculate D1 value. So which character is not matched here? Underscore character is not matched. So which means the shift table value of this underscore is 6. 6 I have taken here. And how many characters matched here? One character matched. What is that one character? Is written here. So 6 minus 1 is 5. And again you check whether which element value has the greater value or not. So this is why Bayer-Moore is different from Hosper algorithm. See here, the D1 value is 5 and the D2 value means if one character is matched, what is the shift table value of that particular character? That is 2 here, which means good suffix table value here is 2. So you just insert these two values to this function, simple function. So 5 and 2, which is the maximum value? Maximum value here is 5. You just shift your pattern towards right side by 5 times. So after shifting this, the value, the pattern is shifted towards right side. Now you check whether all the characters are matched or not. Here B and B is matched, A and A is matched, B matched, O matched, A matched, B matched. All the characters matched. The length of the given pattern and the pattern, the string value here, both are same here. So which means we found this pattern at so and so position. Okay. So here just count down from left to right and you will get pattern found at 17th position. Okay, so this is very important, guys. That is what this Bayer-Moore algorithm is different from Hospital algorithm. You'll be considering many aspects here. One is the D1 value, another one is D2 value. By considering these D1 and D1 D2 value, which value you found it as a maximum element, that you will be considered as a shift value. Okay, so this is how your Boyer-Moore algorithm works. Here, very importance is given to good suffix table. So, how you are constructing the good suffix table, based on that, you will get the efficiency of this pattern matching. And next, we have the time complexity. Best and average case time complexity is, of course, it is almost linear only. Oftenly, that is called as n by m in practice. In worst case, of course, m into m. So the length of the given pattern and as well as the length of the given text. So here, n is called as the length of the text and m is called as a pattern. So if in worst case, if pattern is not found means it is going to calculate the value of O of m into n. Rarely occurs in this Boyer-Moore algorithm. So worst case means there are no characters matched in the given text. That is the worst case scenario. Even though characters are not matched means it's going to consider the value of both good suffix table and as well as bad shift table. If any one of the cases, you may skip complete one by one character matching in the given text. So that is the beauty of your Bayer-Moore algorithm. This is one of the efficient and powerful string matching algorithm. So thank you. If you have any doubt, you can contact me through uh, my email ID, which is already you guys know. Thank you. Thank you so much.